Good morning, everybody. I hope you're having a great day so far. I look forward to working through this homework with you. Hopefully it worked out real well. I will tell you, my goal is that 21 through 28, all those problems went really well. You have a solid understanding about how to work and figure out those. My encouragement was for you to take a look at 67 through 73 odd. And I'll be honest, these problems were really great if you kind of thoughtfully sat and tried to investigate them. And that's my hope. But the funny thing is, if you look on page 115 in your book and look at the examples, it says, well, I'll just grab a calculator and figure it out. And that wasn't my goal in this. But if that's how you did it, that's fine. I'm going to show you the easiest way. We're going to use a calculator. I was encouraging people to try them because I wanted you to thoughtfully think through them because it was going to help prepare you for the things we're getting ready to do. But so here's the deal. Let's talk about 21 through 28. Here's the answers. So go ahead and get out your homework and look and compare what you have to here. I know you have the odds in the back of the book, but you don't have all of them. So 21, cosecant of 330 is negative 2. 22, the secant of 330 is 2 over the square root of 3. 23, the secant of 300 degrees is 2. 24, the cosecant of 300 degrees is negative 2 over the square root of 3. 25, the sine of 390 is 1/2. 26, the cosine of 420 degrees is 1/2. 27, the cotangent of 480 degrees is negative 1 over square root of 3, which is the same thing as negative square root of 3 over 3. I don't know why I chose to rationalize that denominator and not this one and this one, but you know, whatever. And then number 28, cotangent of 510 is negative square root of 3. Okay, in my other class, they definitely were getting most of these and really understood them. So I'm going to kind of fast track working through them. I am going to work through them, but I'm going to move quickly because my expectation is that if there's any of these that you didn't get, you at least kind of set it up a little bit. Here's my hope. If for any one of these problems, if I'm doing 21 and 22, my hope is that maybe you would at least draw. Now they both were dealing with a 330 degree angle. So my hope would be that you would draw the angle. And then I realize that the reference angle inside here has got to be 30 degrees. So then what I'm going to do is I'm going to draw a 30, 60, 90 with the 30 in this corner. I'm going to say that the hypotenuse is 1, which makes the short side 1/2, and the longer leg square root of 3 over 2. And then think about that. If I put that on a coordinate plane, then this point right here is square root of 3 over 2, 1/2. Okay, so if I'm using 30 degrees as my reference angle, then I know my point is going to have these coordinates. They just might be negative, or some of them might be negative. Okay, and so I can use that. Now you got to think about cosecant. Now the only thing is cosecant is the reciprocal of sine, so it's going to be a little bit weird there. But so when I do number 21, okay, the cosecant of 330 degrees, I think, okay, 330 degrees, what's going to be positive, what's going to be negative? Well, it's moving in the negative y direction. So the coordinates of the point I really want are square root of 3 over 2, negative 1/2. Okay? And so then cosecant is always r over y. So it's going to be 1 over my y, negative 1/2. And with fractions, you flip and then multiply, and so that gives you negative 2. With number 22, and you do secant of 330, that one's going to be r over x. So you say 1 over square root of 3 over 2, and then you flip that fraction and you get 2 over square root of 3. And that's real simple, okay? That's just really simple. I'm using, here's my r value, here is my x value, here is my y value, all right? Okay, so as I do these, I'm going to try to move a little bit quicker each time, all right? So for this one, because the reference angle is 60 degrees, the reference angle is not right here. A lot of people think that it is, but the reference angle is right here, and that's 60 degrees, because it would take another 60 degrees to go from 300 to 360. And so the reference angle is 60 degrees. So again, I draw my 30, 60, 90 with the 60 degrees in this front corner. The hypotenuse is 1, the short side is 1/2, the longer leg is square root of 3 over 2. Put that on the coordinate plane, and then I realize that this point right here has the coordinates 1/2, comma, square root of 3 over 2. But I want it down here, okay, down in this fourth quadrant. So that would be down here. So the coordinates of that point still are 1/2, but then it would be negative square root of 3 over 2. Okay, so that's my x and my y, and I know my r is 1. So therefore, secant of 300 degrees is equal to Well, secant is r over x, and so that's going to be 1 over 1/2, and so you flip that fraction and you get 2. Cosecant of 300 degrees is equal to r over y, so you get 1 over negative square root of 3 over 2. So you flip that fraction, you get negative 2 over the square root of 3. All right, moving on. Number 25, now we get into these that are past 360. Now, for some people, these cause a little bit of issues, but guys, hopefully you see, you go, wait, all I have to do is find the angle that's between the terminal side, that's what this is right here, the terminal side and the x-axis. And so that is the reference angle right there, and that's 30 degrees, because it's 30 degrees past 360. So then I come up with 30, 60, 90, where 30 is in this corner. I know that the hypotenuse is 1, so this part is 1/2. This part is square root of 3 over 2. So this point right here is square root of 3 over 2, 1/2. All right, that's easy enough. And so with that then, I know that sine is y over r. Here's my y value. My r value is 1. So therefore the sine of 390 degrees is just 1/2, because 1/2 over 1 is 1/2. Okay, 26. 420. Okay, you got to go all the way around, and then this reference angle right here is 60 degrees. Draw that special right triangle, so you got 60 degrees right here. Hypotenuse is 1, short side is 1/2, longer leg is square root of 3 over 2. That's the coordinates of this point, 1/2 square root of 3 over 2. And cosine is x over r. And so therefore you go cosine theta, cosine of 420 is equal to x, which is that 1/2, over r, with 1. So therefore I get 1/2. All right. Okay, 27. Now this time, not only is it past 360, but it's past 360 and 90 more. It puts us into the second quadrant. Okay, and so for this one, I've got, I look right here, and let's get rid of all of this. I've got the answer, but so I just want to look at this and go, well, the reference angle is right here, and that is 60 degrees. So again, try to think about that special right triangle with the 60 degrees in that front corner right here. I know this part would be 1/2, because this is 1, and this is square root of 3 over 2. So this point right there is 1/2 square root of 3 over 2. But I'm over here in the second quadrant, so my x value would have to be negative. Now cotangent is x over y. So the cotangent of 480 degrees is x, negative 1/2 over y, square root of 3 over 2. The 2's cancel out, and you get negative 1 over square root of 3. And the last problem, number 28. Sorry if this has been boring for you guys. I'm just trying to make sure you fully get it. Okay, for this one, the reference angle, clearly 30 degrees. And so I know that I use my 30, 60, 90. Here's my 30 degrees, 1, 1/2, square root of 3 over 2, except I'm back over here. So it's going to be negative square root of 3 over 2, 1/2. Cotangent, again, is x over y. So I do x, negative square root of 3 over 2 over y, 1/2. 2's cancel out. I get negative square root of 3. And I'm done. Okay. Now, if you tried 67, 69, 71, and 73, I look forward to taking a look at them, all right? But I want to just walk through real basic how the book describes how to do these, because they're trying to set you up for success, and so they're trying to give you the easy way. I was trying to give you a challenge to kind of investigate some things. But what I want to do is I want to take a look at number 49. Okay, 49 in your book, whether you have your book open or not, it's fine. 49 says this. It says sine theta is equal to negative 0.3090, and theta terminates in quadrant 3. Okay? Sine theta is equal to negative 0.3090, and theta terminates in quadrant 3. And so the question is, what is theta if theta is in between 0 and 360? All right? It's got to be in between 0 and 360. And so what I do is I grab a calculator, and first of all, before we grab a calculator, let's do a little basic algebra. We know that if sine theta is equal to negative 0.3090, then we could take the inverse sine of both sides. And these would cancel out, and you would get that theta is equal to the inverse sine of negative 0.3090. Now here's the problem. When I plug this into a calculator, it doesn't actually give me the theta I'm looking for. It may or may not give me the theta I'm looking for. It might be in the third quadrant, it might not. But most likely, it's just going to give me the reference angle. And to kind of ensure that it gives you the reference angle, what you do is you always make this thing positive. Okay, I make that positive. And so really what I say is well, theta is equal to the inverse sine of 0.3090. Now, if I grab my calculator and plug that in, and say inverse sine of 0.3090, I get 17.9989. And so I get about 18 degrees. Now, here's the problem. That cannot be theta. Why can that not be theta? Because theta is in quadrant 3. So this is not theta. This is my reference angle. And so then I have to picture, okay, let's picture quadrant 3. Quadrant 3 is over here. If my reference angle is 18 degrees, that means that this angle is 18 degrees. But it's another 180 to get to here, and then 18 degrees past that. So it looks something like that, and that whole angle would be 198. I hope you can see how we did that. All right? Now, what I'd like you to do is if you don't have a calculator yet, I'd like you to get one, and I'm going to have you try this next one. And we're going to pause this, and I want to make sure that you can do it. Okay? So you don't have to have your book open yet, but you definitely have to have a calculator. You're going to need something with which to write. And number 51 out of your book says the cosine of theta is equal to negative 0.7660, and theta is in quadrant 2. All right? So now what I want you to do is pause the video here for just a few minutes, or however long it takes, so that everybody can figure out what theta is. And remember, theta is in quadrant 2. Okay, so hopefully everybody has it right now, and you go, this is easy. So the first thing I do, I don't know if you remember, but the first thing they said to do in the book is, hey, just get rid of this negative sign. Make that 0.7660. When else in a math class have they just said, get rid of the negative sign? But that's what we're doing here. You grab your calculator, you say inverse cosine of 0.7660. Close the parentheses, and I hit enter, and I get 40.0039. So basically, I get that theta is about 40 degrees. Now, the problem is that's not true. Theta can't be about 40 degrees because theta is in quadrant 2. So this right here is the reference angle. So therefore, that's the reference angle. I want to go to quadrant 2. Okay, quadrant 2, it's going to be 40 degrees up above the x-axis. That's right here. That's 40 degrees. So then I want this angle right here. So I want to go all the way, you think about it one way is to go, well, I want to go all the way to 180 and then go back 40. So all the way to 180, back 40 is the same thing as 180 minus 40, which is going to give me 140, and that's what this angle is, 140 degrees. That's what theta is. Theta is equal to 140 degrees. So I don't know if it would make it better. I don't really love the fact that we're doing this notation and we're using theta in the problem, but we're not actually getting theta. And so I don't know if it'd be better to have written this and say cosine of the reference angle is equal to 0.7660. I know that looks kind of stupid, but it's true that that is the reference angle. It's not true that it's theta. All right. Okay. So here's what you're going to do right now. In your book, you're going to try another 7 or 8 problems that are all exactly like this. They're giving you these obscure angles. They're not the 30, 45, 60, 90 angles that we're used to. They're these odd angles. But you have to use this information, excuse me, and you have to use this information to figure out what theta is going to be. Okay? So what you're going to do is you're going to turn to page 117. And I want you to do 53 through 65 odd. All the answers are in the back of the book. They're all in the back of the book. So here's what I need you to do. I need you to try to work at your own pace, try to keep moving, and check every time you finish 1 or 2 of them, check your answers, make sure you're right. If someone has a problem, it's okay to ask a question, but you guys got to keep moving because we got more stuff we got to talk about. All right? I hope this makes sense. If not, rewind part of the video and I hope it makes sense the second time.